Good morning, dear Professor John Cherry. Good morning, dear teachers and students. It's such a wonderful day for us to be here, Shuiqing campus, for the first 2026 Science and Technology lecture of Xingsong Middle School Education Group. And today we are honored to have a special guest who will give us a lecture about invisible but most important fresh water, groundwater, and global water crisis. First, let me introduce Professor John Cherry first. Professor John Cherry is a top scientist. He's in two top science academies, Canada's Society and America's National Academy of Engineering, and people call him the father of groundwater pollution science. He's won major international water awards. He also helps China with environmental work and earned China's top foreign expert award, the China Government Friendship Award. His book, Groundwater, is a trusted textbook worldwide. And currently, he is also a resident scholar at the Fields Mathematics China Center. Now, let's warmly welcome our guest speaker, Professor John Cherry.
Good morning, teachers and students and guests. It's a great pleasure for me to be here. I'm very happy to be in Shanghai and in China. I'm very happy to be in China because it's a wonderful country that's developing very well. And when I come to China, I'm always pleased to see the progress. But I'm from Canada, a cold part of Canada, so I'm also happy to be in Shanghai at this time of the year, because in Canada it's very cold and snowy and icy. And when I was your age, I used to enjoy the snow and ice, but at my age now, I'm really pleased to be away from it. So on Canadian scale, this would be a nice warm day, and I see you all have coats on, and for you it's not a nice warm day, but it's a very nice day for a Canadian. So the topic is water, and I believe that in education, water should be the foundation of learning about science. So water is important because, of course, it sustains all life, but we take it for granted. Now, we human beings and all other little creatures are composed of molecules. And a human being has trillions of little molecules, but in fact, water makes up 99.4% of all of our molecules. Now, we're 70% water, but in terms of molecules, water is what we are. And this is similar to all living creatures. We're just basically a bunch of water molecules. But this talk is focused on a particular part of water, groundwater. So for those of you learning English, then this is the word to focus on in this talk. But groundwater is hidden. So the purpose of this lecture is to make us understand this hidden water. So we see the water in streams and rivers and lakes and wetlands, but nearly all fresh water is what we cannot see. So nearly all fresh water is under the ground. So the underground water then is 99% of all liquid fresh water. So when it rains, or when you look at a lake, or when you look at a river, you're really not seeing much of the water at all. So when you look at fresh water, we have to imagine the water that you can't see. So this talk is about imagination. So we all know then that icebergs, when you see an iceberg, you only see the tip. So when you see a lake or a river and whatnot, you're really only seeing the tip of all the real water. So the problem is that we have a global freshwater crisis. The planet is running out of water, and too much of our fresh water is polluted. And China, like all countries of the world, pretty well, most big countries, is running out of water and has lots of pollution. So we need more young people to become educated to help solve our freshwater problems. So there's a lack of people who are highly educated with respect to fresh water. So we commonly see photographs of this, the Yellow River in China, for example, going dry. And we all know that rivers go dry. Many rivers don't flow to the ocean anymore. But the land is going dry. So what's going dry is the underground water in many places. So when we see rivers looking like this, it's mostly because we've removed most of the groundwater, because it's groundwater that feeds the rivers. Now this is a very important diagram. Please look at it closely. I took it from the web because it looked good. But when we look at it, when we think about it scientifically, it's missing pieces. So in essence, this lecture is about paying more attention to what is the so-called water cycle. So we'll see this diagram again in many forms, and later on in this lecture, I'll stop the lecture and I'll ask you for your critique. I'll ask you to look at the figure and tell me what's missing. So the study of science is mostly about trying to figure out what's missing. And this is the word to pay attention here to now, and you'll see it on many of the figures. At the bottom of this diagram, we've got an arrow. It says groundwater flow. We have all these other arrows. We've got an arrow coming from the river, which says evaporation. The water molecules are coming out of the river and going into the sky. We've got another arrow coming from the greenery, transpiration from the plants. That's very important. And so this is the hydrologic cycle with all these arrows. Some arrows go up, and then precipitation comes down. And one of the big problems in the world at the present time is that rainfall isn't happening where people need it. So human beings have done so much change to the landscape that rain isn't occurring as we would want it to be occurring. So this is a very simple little diagram, but it's very, very important. It's very accurate. So this diagram shows a little sketch of a tree. And from the tree we have moisture going up into the atmosphere. So the moisture forms clouds. And the clouds move, and then we have rain. And the rain goes back down into the ground. And at the bottom of this diagram, that doesn't show up very well, but we've got groundwater. So one of the points of this diagram is that trees have roots. And the roots go way down into the ground. And for most trees to survive, the roots have to go down to get the groundwater. So when I say that groundwater is important, then we can't have forests unless we have groundwater at a level where the roots can get them. This is just another little sketch that shows when it rains, water goes onto the ground and flows off as overland flow. And then some of the water goes down below the water table. So whenever it rains, the rainfall does a number of things. Some of it runs away, some of it evaporates, and some of it goes down into the ground. So if we change our landscape, and if we do the wrong type of agriculture, and if we do too much pavement in our cities, then we don't have enough water getting down into the groundwater zone. And I'll talk about that as we go along. So So here we have another one of these diagrams. So this is also the water cycle. So when you look at books, or if you go on the web and you want to understand the water cycle, you see many different versions of what the water cycle is supposed to look like. But most versions are misleading or they're wrong. They don't portray the water cycle the way it needs to be portrayed. So later on, we'll look at this diagram again, and I'll ask you, what's wrong with it? And of course, the challenge for students is when you look at books and you look at diagrams, the question you always need to ask is, what's wrong with it? So trees are important. Everything that grows is important. It's important to the water cycle. So what we human beings do with our growing then affects the world we live in. So the food affects the world we live in, because when we cut down forests to grow food, then we're changing the water cycle. So everything we humans do on the face of the earth changes the world we live in. So we need to be able to imagine in our minds what is happening in the underground. So this talk is about imagining what's happening in the underground. And in education in general, we talk about what we know and what we can see and what we can write down. But in general, what's even more important in many cases is what we need to imagine. So here's a sketch drawn by an artist. So this person is imagining what's in the underground. And this sketch shows holes and pockets and various types of underground materials. But what it doesn't show is the water that's contained in the cracks and the holes in the materials. So groundwater is the water that's contained in all the space in the underground. But another important part of nature is also underground. Look at this amazing diagram of a tree. I spent a lot of time looking for a diagram that shows a tree the way a tree should be shown. And why is this so important, this picture of a tree? It's so important because nearly all of the tree is not above ground where we see it. The tree is mostly below ground. And you almost never see pictures of trees like this, because people who take photographs of trees, you don't see the underground. And when you're drawing a picture of a tree, generally you don't know that this is what a tree looks like. So there's more parts of the tree underground than there is above ground. Why is that? So the roots of the trees are looking for what they need. The roots of the trees are looking for water, and they're looking for the chemicals that they need to grow. So the trees keep growing their roots farther and deeper. So the roots of many trees have to go down to the groundwater zone. So people don't know about groundwater in general. They know about lakes and rivers and streams. And in general, we don't know what trees are like. Trees are amazing. So what if you wanted to go and see groundwater? The easiest place to see groundwater is to go to a beach. So here we see the water at the top of the slide. Okay, that's the lake. And then we've gone into the sand and we've dug a hole. What appears in the hole? Water comes up in the hole. And then it just sits there. So we look at the water in the hole. That's groundwater. And the water level, that's the water table. And then there's always a depth to the water table. So if you're a hydrogeologist like me, when I think of the landscape, I'm always trying to imagine, like, where is the water table? How deep is it? So if we went outside onto your schoolyard and found some soil and dug a hole, where would we find the water table? Well, in Shanghai, there's water everywhere. So if we dug such a hole in Shanghai, we'd find the water table maybe down a meter, maybe down 2 meters. So everywhere below Shanghai, we have groundwater, and we have the water table. Now, if you go out in the city and dug a hole, you might not find the water until you go deeper, because you've got buildings with basements. So human beings then pump the water out so the basements don't have water in them. So a city becomes a complicated place for the water table. But if you go out to a park in Shanghai, into the middle of a park and dug a hole, you'd find the water table at a meter or 2. And it would be there, just staring at you. And we'll talk about what that water would be doing here in a moment. So groundwater is everywhere. And anywhere you drill or dig a hole, you'll find water. And almost always that water will be fresh water. So how did human beings long ago, before there were trains and airplanes and roads and whatnot, how did they find their water? Like, how did human beings survive without water when they arrived long ago, thousands of years ago? Where did they get their drinking water? Now we take it for granted. Now, whenever it rains, the water goes into the soil, and the soil has particles, grains, and then the water goes down to form a water table at the bottom of this slide. Now, if we were to drill a well, and on the left we have a well, and we're looking down that well, and I think you can see the reflection. So we're seeing the water level in the well. And that white thing going down the well is measuring the water level. But what's important then is we have to imagine what we're looking at. So this diagram is our imagination of what we're looking at. So as scientists, we would always draw a diagram that would show what we're looking at. So we see the well, and down the well we see a triangle. That triangle is the symbol we use to represent the water table. And then we've got groundwater. So how do we groundwater scientists study groundwater? Well, we dig holes and we drill wells. That's how we study it. We dig our holes and we drill our wells, and then we draw pictures. And the pictures are what we imagine. So this is just a map of your country, and the next few slides are going to be in the vicinity of Dunhuang, out on the Gobi Desert, where we visited many years ago in this large country, China. And there's a desert out there, the Gobi Desert, which shows the southern part of the Gobi Desert, and the rest of it's in Mongolia. So we're going to look at a slide now of a desert that my wife Doris and I visited long ago. So we're driving out on a desert because we're going to look at a particular part of the desert with some geologists for a particular reason. And we're driving along and we see some rocks piled up, some stones piled up. And when we got out then, the question, well, why are those stones there? And when we looked down to see what we would see, we saw water. Okay, so the stones are piled up because that's what was piled up when the people who were traveling across the desert decided to dig a hole. Okay, they decided to dig a hole so they could find fresh water. But what were they doing in the desert? They were nomads, traveling across the desert on camels. And they had animals. I guess they had goats and sheep. And every once in a while, when it would rain, there'd be enough grass for their animals to live. So if you're traveling across the desert, then you have to have drinking water. And this was their drinking water, the bottom of this hole, which is 6 meters down. And the desert's very dry, and the soil can be salty, but the water beneath the desert is fresh. So what did we see? We didn't see camels and nomads, but we saw a little yurt. This is a collapsible dwelling that the nomads who travel there even now, this was 20 years ago, would use to live in. And then they don't have camels now, they have little tractors. So the nomads were there. They weren't there for us to meet them. They were somewhere else. But they're there near the well. And the point of this is to emphasize that groundwater is everywhere, and that's why human beings have been able to survive. So if we're going to think about this scientifically, we have to draw a picture. So this would be my picture of what we have there. So you can see the well, and then we've got that triangle, that's the water table, and everything below the water table then is groundwater. And if you were to drill a hole deeper and deeper and deeper, eventually the groundwater would have salt. So when you drill deep, the groundwater all has salt and you can't drink it. But if you're just shallow, then you'll find fresh water that's drinkable. And if you go onto the web, you can see many pictures of dug wells. And 200 years ago or 300 years ago, many of the people in the world got their water from dug wells. So how did the people in China live 1,000 years ago? Well, they mostly lived from getting their water from dug wells. But they would dig by hand. Some of them would be 30 or 40 or even 50 meters deep. I guess I need help. What did I do wrong?
Okay.
Oh, no problem. Thank you. So wells like this were what people lived from a few hundred years ago, everywhere across the world. So this is a picture from a book. And it's a picture then of how we should imagine the underground. So there's a water table everywhere. And in this picture there's a dashed line, that's the water table. So above the water table the soil is wet some of the time, but below the water table you've got groundwater flowing. And the groundwater can either be occurring in the cracks in the rock, or it can be occurring in the pore spaces in the gravel. So groundwater fills the spaces, but it flows. And in most areas, it flows to surface water. So you can see these arrows, and they're flowing to the lake. So when we think of groundwater, we have to realize it's always moving. It's going from somewhere to somewhere else. It's not like a lake or an iceberg. So water is flowing. It's like a river, but it's flowing very, very slowly. So when we look at magazines, we see pictures of animals. Human beings like to look at animals in magazines. Here we have zebras and other animals in Africa. And they're going to the water hole. So the animals can exist in dry parts of the world, like Africa, because there are water holes, places that the animals can all go to get their water. So the question is, well, where does this fresh water come from? So as I've been suggesting, we need to draw a picture. Okay, so now in the future, when you look at pictures of animals at water, you're trying to imagine, well, the water, they need the water or they're going to die, but where's the water coming from? And is the water polluted? So groundwater seepage feeds the water holes. So if it weren't for groundwater that we can't see, then these animals couldn't be there. So the pond is surface water. That's what we call it. But the water in the pond has come from groundwater. So here's our little picture. So the pond has a water level, but when we go out into the land then, that pond water level then goes out into the land and then it becomes the water table. So that triangle then is our designation for the groundwater level. So if you dug a hole in the ground not far from where the animals are drinking their water, you would find water in the hole. That would be groundwater. And you know that the water would be fresh because the animals are able to drink it. So what happens when the water table drops down a few meters? So if the water table dropped down a few meters here, these water holes would dry up. And then the animals would have to wander off and find other water holes. And when long periods of no rainfall occur, then the animals, most of them disappear because they have to have their water. So the water table has to be kept fairly high, and for that we need some rainfall. Now this is a slide from Dunhuang out on the Gobi Desert where there's nothing but sand. But here there's a little lake near Dunhuang, and this is an oasis. So of course you've all heard about the Silk Road, where people traveled from China to Europe hundreds of years ago and even thousands of years ago. The Silk Road was the road by which people moved from the west to the east. And how could they do that? They would have to have fresh water. And where would they get their fresh water? The only fresh water would be at the oases. It could be many hundreds of kilometers between the oases, so they'd have to make it with their camels from oasis to oasis. And this is what Dunhuang Oasis looks like today. It's a very famous tourist area where you can go and ride a camel and stay in hotels and look at this water. My point being is, where does this water come from? Well, it's groundwater. So that's where the water table is. Now this is another picture to help our imagination. We have water and horses there along the river, and so the people who studied this then have drawn a picture. And on the upper right then, they've drawn a picture of mountains, and then they've drawn a river in blue, and around the river they've got green, which is the vegetation. And they've labeled this river as a gaining stream. And you can see the label below the river saying groundwater discharge. So it's a gaining stream and the river has groundwater discharge. So what's that telling us? That's telling us then that this river is receiving groundwater. So the river is a healthy, good river because it's receiving groundwater. Now if you also look at that diagram, you see arrows. Arrows coming from where the mountains are, and those are groundwater flow arrows. So in many parts of the world, the mountains have more rainfall and they have glaciers. So the mountains receive water into the rock, into the cracks in the rock, and then that water travels. In some cases it travels for thousands of years and eventually gets to the river where it discharges. Now the other diagram then shows it in more detail. So it shows the stream, and it shows the trees along the stream, referred to as phreatophytes, and it shows that the stream is maintained by groundwater. So if we human beings, or if nature changes the climate, or if we change the landscape, Or if we pump too much groundwater, then we would change the stream. And that would change everything. So this is another picture of the land. And this picture is very different from anything else. It shows caves. It shows openings. At the bottom, it shows an underground lake. So this type of land is called karst. Look at that word. It's interesting to know what it looks like in Chinese. So karst terrain occurs around the world, and 15% of the global population lives on karst terrain. There are more people in China by far living on karst terrain than any other people in the world. Karst topography is more important to China by far than any other country in the world, except some very small countries. So karst terrain has caves, and that allows human beings to go inside the caves to see what they can see. So if you're interested in caves, then China has some of the most nicest looking, interesting caves in the world. You can get on a fast train and you can go inside caves within the same day. China is so amazing. So caves are common in karst, and that allows us to go inside them and study them, which the next slide will show. Look at this. That's amazing. We won't worry about what these words are on here. These are all scientific words, some of which don't mean much to anybody but an expert. So typically in caves, you've got these spikes coming out of the ceiling. They're like icicles, but they're formed of minerals. So how would they form? So all caves leak. So there's land above the cave, and when it rains, the water flows into the rock, and then some of it drips down into the cave. So these spikes coming out of the ceiling, they formed from the chemistry of the water dripping down from the ceiling. Okay, they're formed of calcium carbonate or limestone, CaCO3. And now from the bottom of the cave, you see spikes going upward. Not sure if spikes is the right word, but that's the word coming to mind. So you've got these icicle-looking things coming down from the top. You've got them growing up from the bottom, and that's because when the water drips down from these spikes in the ceiling, it hits the bottom of the cave, and then it forms more minerals. So the cave is a cavern. It formed hundreds of thousands of years ago, and now it's filling up with minerals that are creating the same rock that the cave formed from. But it forms these very beautiful features. So caves are amazing, and in China you've got lots of them. And in China, hundreds of millions of people live on karst. And you'd say, well, is this good news or is this bad news for people? I hope to remember to comment on that question. So here's a map of China, of course. And the orange color is where you have karst at surface. So karst at surface means you can see the rock, and it's got holes, and it looks in a very different way. The blue is where you have a karst under. No, sorry, I've got this wrong. The orange is the karst that's below the surface. The blue is the karst at the surface. Okay, so China has lots of karst. So China has a few hundred million people living on karst. Now we can categorize streams according to their interaction with groundwater. So the next few slides will ask us to imagine what rivers and streams look like. So in the upper diagram, we have a stream, and in this case, the water is seeping out the bottom of the stream. And in the lower diagram, then, on the right, the water is seeping up into the stream. And on the other diagram, water is seeping out of the stream. So most streams, except in a very dry climate, have groundwater seeping into the stream, unless human beings change that. So on the left, we then have a losing stream. Okay, that means water is being lost from the stream. Okay, that means that the water in the stream has to come from rainfall. So here we're back to our diagram of before, just to remind us that we have a water table and groundwater is always flowing, and in most cases groundwater is feeding the stream. So when we imagine groundwater, we should think about how fast is it traveling. And in deposits like sand or gravel, it's usually traveling, less than a meter a day. So it might be traveling a few centimeters to a meter a day. In a river, it would be traveling at hundreds of meters an hour or so. But in rock, the water travels in the cracks, and it travels a bit quicker. So in many, many years, then groundwater can travel a very long distance. It can travel many kilometers. Now, groundwater scientists then, we can't just imagine anything we want to imagine. So if we're going to draw diagrams and pictures, we have to put wells in the ground. So we drill holes and we put pipes in the holes. And the pipes in the holes then, at the bottom of the pipes we have holes in the pipe. So water rises up in the pipe and gives us a water level. And if we've got two pipes, then we can have two water levels, and we can measure the distance, and we can write a little formula. And this formula says that velocity equals K, which is the nature of the soil, and N, which is another aspect of the soil, and H is the difference in the water level. And L, delta L, is the distance between the wells. So we groundwater scientists put wells in the ground and we make measurements, and from that we can do some arithmetic to determine how fast the water moves. So just a little bit of arithmetic and a few wells, and we can figure out what direction the groundwater is flowing and how fast it's flowing. So when we see a river such as this, and it's not raining, and it's a nice day, the question is, where does the water in the river come from? And as my previous slides have shown you, in most cases, the water in the river is groundwater that's been seeping up into the river. So groundwater needs to be seeping up into the river in most places in order to have flowing rivers. So if we pump too much groundwater, we're not going to have flowing rivers. So why would human beings pump too much groundwater and cause the rivers to dry up? Like, why would we do that? Why would we human beings pump water so much that the water table goes down and the rivers dry up? Well, because we need the water. What do we need the water for? When we pump water out of the ground all across China and all across the world, and we're pumping too much water, what do we need the water for? We need the water to grow food. So, we human beings are pumping too much water. We're causing lots of problems. We're causing the rivers to dry up. We're causing the fish to disappear. We're causing the animals to have problems. And we're doing that because we need to grow food. So, Everybody in this room is involved in eating the food from pumping too much groundwater that's causing the rivers to dry up, that's causing the animals to have problems. Interesting. So we're all part of the problem. And we'll get to that a little bit more. So the water crisis is about pumping too much water and polluting too much water. And of course, we human beings know that we should stop that, but it's hard to stop it because we need the water. But we've got to reduce our abuse of the water. Okay. So this is a particular type of fish, and it's in a river, a nice clean river. And so how can that fish be there? This particular type of fish can only be in this river if the river is receiving groundwater. So in the hot summertime, the fish needs cold water. So the fish goes to where the cold water is. Okay, where's the cold water? The cold water is where the groundwater is flowing in, because in the summertime, the groundwater is cold, relatively speaking. In the wintertime, the groundwater is warm, relatively speaking. So if we pump too much water and we cause groundwater to not flow into this river, but we cause groundwater to flow out of the river, then the fish all die. And there are parts of North America now where people are fixing the rivers so that the groundwater flows in again so that the fish can come back. So human beings are pumping too much water, and here we have photographs of water coming out of pipes. Okay, and this water is coming out of these pipes because there are wells nearby, wells pumping water from the sand deposits. And then the lower right diagram shows how we use the water to grow crops. In most places we use it to spray it on the ground. Okay, and this is called irrigation. And China does a lot of irrigating, as do most countries of the world that produce food. So in general, we're irrigating too much. There are too many of these irrigation systems just pumping water out. And on a hot day, what happens to most of the water? It evaporates. So we human beings are pumping water out, we're spewing it out on the ground, we're growing our crops, and much of it's being lost by evaporation. So that's wasteful. So we're figuring out how to do it better. China's figuring out how to do it better in many ways. So why is groundwater important? Well, it's important because it's almost all fresh water is groundwater, and it's important because water is pumped from wells, provides drinking water. So half the people in the world drink water from wells. And then 40% of our irrigation, or 70% of our irrigation, is from groundwater, etc. So water is very important, of course, as a resource. Groundwater is not important to people in Shanghai because your water is river water that's treated. But all the country people in the world and in all the small towns, they drink water from wells. So this is our imagination showing us what happens when we pump a well. So we have the dashed line with the triangle, and that's the water table. And when we pump the well, the water table goes down. So here we see the dashed line going down. So we've drawn down the water table. And then over on the right, you can see a stream. And this stream, under this condition, then the arrows are showing that the water is moving into the stream. So the fish and the animals around this stream, they're okay, because we're not stealing the water from the stream. But if we pump the well too much, then we're stealing water from the stream. We're stealing water from the fish and the animals and the trees that live along the stream. Okay, so we pump this well a lot more. You can see that the water table has gone down. And the water table has gone down all over the place. And the water table has even gone down under the stream. So all of the fish in this stream that depend on groundwater, they're all going to die. And the stream may dry up, but it won't have the water that it had before. So what have we done? We've lowered the water table too much. And that's happening in many, many parts of the world. So we human beings then, we pump our wells too much and we're stealing water from other parts of the system. And stealing is a good word because that's what we're doing. We're taking water from other parts of the system that depend on the water for survival. So this is the map of the world, and these blue areas are where there are aquifers. And aquifers are deposits of geological material. They're buried deposits of sand in general that we can put wells into and pump water out. And China has 2 or 3 huge aquifers. But the point here is that 1/3 of the aquifers around the world are depleted beyond recovery in human time. So that means that human beings have pumped them so much that the water level's gone down so far that the aquifers are drying up because we're pumping too much. But if we stop pumping, it would take tens or hundreds of years for the water levels to go back to their original state. So if we stopped our pumping, it would continue to rain, and eventually the water levels would recover, and everything would be going back to normal, but this would take decades or hundreds of years. So that's called depletion. Oops. So China has 1 or 2 of the largest aquifers in the world, and one of the Chinese aquifers was being depleted a lot. So China built the south to north water transfer scheme. So China has so much rainfall in the south that you can solve these problems by transferring water to the north by doing lots of engineering. And so China is fixing a lot of its too much pumping problem, and will continue to fix as time goes by. So what else happens when we pump too much? So the land in Shanghai is going down. Okay, so you don't see it, but your land is sinking. And it's sunk by a few meters or so over the last 100 years. But a city by the ocean is going to have problems if the land keeps sinking, because then the ocean can come in. So Jakarta in Indonesia has sunk by 10 meters. So the ocean is starting to flood Jakarta when the wind blows, and Jakarta is building a new city, and they're going to have to build walls to keep the ocean out. So Shanghai used to be sinking too much. Why was it sinking? It was sinking because you were pumping too much groundwater. So Shanghai used to pump too much groundwater, and your city would sink. So you stop the sinking by not pumping groundwater too much. So when you pump an aquifer, the pressure goes down. When the water pressure goes down, then the land can sink, because the pressure isn't there to hold up the city. Parts of Taiwan were sinking too much. And the government told the farmers and whatnot that they were to stop pumping so much groundwater. The farmers didn't want to do that because then they would lose money. And then the Taiwanese government decided they would put farmers in jail if they continued to pump too much, because the sinking was so important. So why did sinking become so important in Taiwan? It's because they built a fast train from north to south. And when you build fast trains, you can't have the land surface changing its surface. So no more sinking in Taiwan, no more too much pumping, because the fast trains have to function. Not an interesting way to stop too much pumping. So there are dozens of big cities around the world that are sinking too fast. And you probably heard that the glaciers are melting, and that's causing the oceans to rise. Okay, you probably heard that. Well, that's incorrect. The melting is so slow that the rise of sea level caused by glaciers melting is almost insignificant. So people who live in the big cities shouldn't be worrying about the glaciers melting. They should be worried about too much pumping. So why is too much pumping such a hard problem to solve? It's because wells are hidden. You don't know where all the wells are. You don't see any of the wells. In many cities, the government doesn't even know where the wells are. So stopping a city from sinking is a very difficult job for governments to do. And in China, you stop the worst of the sinking. Beijing has been sinking. Doesn't matter so much if Beijing sinks because it's not near the ocean, but it matters a lot if Shanghai sinks. All right, so this is all caused by groundwater, the thing that we don't see. So let's return to the water cycle. All right, so this is a figure, taken from the web, and it's somebody wrote a book, and they put this figure out there, and they said this is the water cycle for children to look at. So what's wrong with this figure? This figure is seriously wrong. This figure is missing a very important piece. So this figure is what a certain person imagined the water cycle to look like. Okay, that's this person's imagination. And they're missing a very important piece. A piece that is so important that looking at this figure irritates me. All right, so what are we missing here? Any suggestions? Yes? Right. So now I'm happy. Very good. It's got nothing to do with groundwater on it. Like, how could they be so stupid? Well, they haven't been educated about underground water. So 99% of all liquid fresh water is groundwater, and this figure doesn't have it on it. Okay, that's because no books give the number 99%. It wasn't until a few years ago that I saw that number in a book. Okay, so now we're going to fix this figure. So the figure has trees, but when you draw a tree, we have to realize that most of the tree is under the ground. The tree's a tree doing important work for nature because it's got roots. So when we think of a tree, we need to think of this. And you never see pictures in books that show a tree in its majestic state. In its majestic state are all these roots. This is a very famous figure that you only see very, very rarely. And it's from illustrations, and the illustrations say the door of perception. Isn't that interesting? The door of perception. And this tree figure is from a book with that title. So we need a figure then that shows the roots. Let me see if it does. It doesn't. So we've kind of lost from this figure the roots, but you can imagine the roots. The important thing is that the word roots is on there. So what's really important then about this figure is that the trees have roots. The roots go down into the underground water, And that water is pulled up into the tree, and it's pulled up into the leaves. And the leaves emit then some of that water to the atmosphere, and that's transpiration. And this transpiration goes up, and it forms clouds, and that forms the rain. So in parts of the world, rain is disappearing. And it's a serious problem because people can't grow their crops. And so why is the rain disappearing in some parts of the world? It's because we're cutting down the trees. Now this is a slide that I just found recently. Very, very important slide that I wish I'd seen long ago. And it's a scientific plot then of the maximum depth of the roots for different types of trees. And there are many, many different types of trees where the roots go very deep. So in all the lectures I've given in my career and whatnot, this slide I just found recently, and it's so important because when we look at all these different types of trees, we have to realize that roots are going down how deep? Like they're going down 10, 15, 20 meters. Okay, so on the right, we've got our majestic tree with roots. And on the left, we've got a photograph of healthy living soil. So this healthy living soil, it's dark color. It kind of looks like dirt. Okay, it's brown and black. And it's healthy because it's brown and black, and it's got lots of roots. Okay, that's one reason why it's healthy. But it's mostly healthy because it has creatures. So it's got thousands and millions of little creatures living in the soil. So the trees have hundreds and thousands of little rootlets extending down into the soil. The soil has thousands of little creatures. And so I just want to remind us here that when we cut down the forests and when we disturb the soil and do bad things to the soil, we're killing all the little living things that these things have. So to remind us then, everybody sitting in this room is eating food that is likely doing harm. In some cases, the food is grown by pumping too much water. And when you look at a satellite view of the Earth or whatnot, and if you're pumping lots of water, you're going to see these green dots. What are the green dots? The green dots are where these irrigation systems that are connected to wells operate. Now, this photograph here is from a part of the United States. It's from Nebraska. And Nebraska has a very big aquifer. This big aquifer in the United States then produces 1/6 of the world's grain. Comes out of the part of the United States going from the north to the south. It goes all the way from South Dakota to Texas. One of the biggest aquifers in the world. It allows the Americans to grow lots of grain to ship around the world. Used to ship a lot of grain to China, and now it goes to Japan and whatnot. And that's all happening because this groundwater is pumped, like we see here. But it's pumped away too much, and this aquifer is drying up. So in 20 or 30 years, this aquifer will have dried up to the point where the Americans won't be able to ship this grain around the world. So what we do in one country can affect the food in another country. We're all connected. Now, when we pump too much water in the wrong way, all water has a bit of salt in it. So even though the groundwater is fresh water, it has salt. And when the water dries, it evaporates, the salt appears at the surface. So then we have soil that's being destroyed. So we're destroying soil by pumping too much water that produces salt that ruins the soil for agriculture. So modern agriculture is our enemy. It's the enemy of humanity. What is modern agriculture? Modern agriculture grows monocrops, only one crop for as far as the eye can see. That's not good for the soil, and it's not good for ecology. Modern agriculture uses pesticides, chemicals that harm life, that we spray from airplanes to kill the creatures that are harming the crop. Modern agriculture uses chemical fertilizer that destroys the soil. Not only that, but modern agriculture produces food that doesn't have as many nutrients. So the food we're all eating now that we buy in our grocery stores that looks so good is not as nutritious as food used to be. Modern agriculture is doing too much irrigation that's drying out the land. So we need to switch from modern agriculture to ecological agriculture. And China is one of the leaders in ecological agriculture. China's trying to change, you're trying to change your agriculture. But at the present time, your ecological agriculture is only 1 or 2% of your agriculture. So this is going to be a very big job for your government to make this change. We're going to have to eat food differently. So what about soil? Okay, soil looks like this. So if you had a microscope and you actually looked into the soil, it's living. So if you pour chemicals on the land that harm the living creatures in the soil, then you're harming the system, and it's not sustainable. I like eating blueberries, so when I go into a grocery store, I'm always looking for the blueberries. And then it's very interesting when you look at blueberries to look in the package and see where they were grown. Most blueberries that are grown and sold in the stores in China and Canada come from Peru. And so when I investigated that, I find that the blueberries grown in Peru and many other places are not sustainable. They're grown by pumping too much groundwater. So the local people are growing the blueberries, companies are making the money, the blueberries are shipped in airplanes all around the world, people like me eat them, and when we're doing that, then we're actually harming the water cycle. So we need to be growing blueberries that don't harm the water cycle and the soil. So there's so much drying out of the land then that we have people like this that are having to move because their groundwater's dried up and they have a drought. So the water cycle is causing all sorts of hardship across the world. Water is being polluted, so when you sample your water, in many cases, almost all the surface water is polluted to some degree. And this is a paper written by an Australian who's an expert on China and by a very distinguished Chinese scientist, The Global Drain, Why China's Water Pollution Problem Should Matter to the Rest of the World. And the point of this slide is not to say that China is a bigger problem than any other country of the world. That's not the case. The point of the slide is to show that if China has pollution problems, it can be affected by what's happening in the rest of the world, and what China produces that causes pollution is relevant to the rest of the world. So the whole world is trying to rally around being more sustainable, and China's working on it harder than most countries. So let's imagine what's happening beneath Shanghai or beneath any city. We've got garbage, and we've got gas stations, and we've got salt. So any urban area around the world and going beyond the world has activities, and most of these activities cause pollutants to move downward. And if pollutants move downward, then where are they going to end up? Okay, they're going to end up in the water table, because the water table is everywhere below us. So whenever we leak or dispose or put something into the ground or into the sewers that leaks, then some of it ends up in groundwater, creating groundwater contamination. And this is the most difficult problem of all. The most difficult pollution problem to solve is the groundwater pollution problem. Because you can solve rivers, you can make rivers cleaner by just cleaning up what you put in them. Okay, you can clean up lakes by stopping the inputs. You can stop air pollution as you have in Shanghai by just stopping the inputs. But you can't clean up groundwater by stopping the inputs because the inputs have already occurred over many decades and the pollution just continues to move along. So agriculture is the biggest problem and we have to change the way we grow food. This is a book by an American who looked at all of these things, and his conclusion was to feed the world with its ballooning population without destroying the planet's land and water is likely the greatest challenge that humanity has faced. Okay, and this is true for all countries. This is true for humanity. And you probably hear most of the time that what human beings have to do is to stop putting CO2 into the atmosphere. Okay, that's what we're all taught. But the biggest problem is to fix the growing of food problem. So this is a conclusion that others make, and this is just saying what I told you, but it comes from a newspaper. We all agree on this, that food is what needs to be fixed quickly. This is just a slide from a newspaper. But China's goal is to cut its meat consumption because meat is the primary cause of all the problems. Because when you eat meat, particularly beef, it takes so much crops to grow the food to feed the cows that if you cut down on beef, then you cut down on agriculture doing all of its harm. So Americans and Canadians are the biggest beef eaters. So we're having to cut down on beef. You Chinese are being told that you've got to cut down on pork. How could the Chinese ever cut down on pork? Well, maybe you don't have to cut down on pork eating, but you need to cut down on eating pork that's not grown sustainably. So a few weeks ago, Doris and I visited a pork farm in Shanghai that's growing organic pork. This farm is a factory. It's got 4 floors. So in this pork factory in Shanghai, there are 4 floors, and each floor is full of pigs. This factory is the only factory for pigs in the world that causes no pollution. It's the only sustainable pork production place that we know of in the world, and it's being built in China with subsidies from the Chinese government. So one factory in Shanghai, out in the countryside in Shanghai, this particular pork factory with 4 floors and thousands of pigs produces the pork eating equivalent of 3% of Shanghai's pork. Now that's a huge number. It means then that all the pork you eat in Shanghai could be grown in a factory that would then cause no harm. This pork factory produces no waste into the ground. It produces methanol, and it actually makes organic fertilizer. So that's the future of food production. The future of food production is food that doesn't harm the earth. So when you go into a grocery store, look for the food that has an organic label on it. And you're likely not going to want to buy it because it costs more. So why does it cost more? Because you don't get to destroy everything by making it. But if you put a value on nature, then it doesn't cost more. It's actually the only food that makes sense. And China is making big advances in this to lead the world. So what happens when we cut down too many trees so that the forests disappear? Okay, that means these trees don't produce moisture into the atmosphere. So there are countries that have gone from being wet to dry because they've cut down their forests. Okay, I mentioned that. So when we cut down the trees then, we're not getting transpiration. So vegetation is the key to a healthy world. Quickly here then. So here we have some photographs of mountainous country. Okay, and look at the one for China. Like that's an art photograph that I photographed from an art museum. Okay, what are we looking at there? This is terraced agriculture in the mountains of China. The same in Indonesia, and Vietnam, and the Philippines. So what are people doing up in the mountains in China? What are the farmers doing? They're growing things. They're growing rice and other things in the mountains of China. And so how can they be living up in the mountains of China? What allows people to live where they live? At the end of the day, what do they require more than anything else? They require drinking water. Where are people in the mountains of China going to get their drinking water? They have to get it from springs. What are springs? Springs are where groundwater comes out at the surface. What are mountains made out of? Mountains are made out of rock. The rock has cracks. The water flows through the cracks and forms the spring. And if the people find the springs and they use it for drinking, then they can live there. So what are all the little farmers doing up in the hills of all the mountains of China? And that's more than 100 million people. Okay, they're growing their crops and they're living their life and they're eating their food and they're drinking water from their springs. So if we're going to draw a mental picture of a mountain, this is the way I draw it. There's a water table in the mountain. So what's a mountain formed of? A mountain's formed of rock. The rock has cracks. The cracks have water. The water flows to springs, and people could live there if they find the springs. So if you're walking up a mountain and you're not seeing any people, that means that there's no water table. It means they don't have springs. So long ago, Doris and I, my wife and I, went walking up in the mountains in Yunnan province. Y-U-N-A-N, Yunnan. And we looked at many villages getting their water from springs because we wanted to see what were the springs like, and what was the water like. Well, this is what the springs look like in some villages, and here's what they look like in other villages. Now, this is 20-some years ago, 15 years ago, so these springs are polluted. They're polluted by bacteria from the human waste and from the animals, because the farmers all have pigs and chickens and things like that. So this water is causing people to be unhealthy and children to die, etc. These springs are fixed up, but the water still is polluted to a significant degree. So to get springs that aren't polluted in the mountains is a challenge that needs to be fixed. Were the people happy up in the mountains living off the springs? Well, they looked happier than in the cities because they were free to have their farms and to grow, and they were leading actually quite a very interesting life, growing their agriculture, taking their agriculture to the towns for sale, and they lived out in the healthy weather countryside. And here's a slide of one of the places we visited along the New River. It's a river in the far southwestern part of China that borders on Myanmar. So here's a village. So how can these village people be there? They can only be there if they have groundwater feeding out of springs. This is what it looks like, a bit more. So we have a paradox. We have too much water being pumped in some areas and not enough water being pumped in other areas. So this is the paradox facing humanity. And we have more than 1 billion people who are living in water poverty. So a third of humanity is now in water poverty. 40 years ago in China, you had many people living in water poverty, and now you don't, because you've provided water for everybody. So if you're living in water poverty in Africa, what does your life look like? If you're a woman or a child, you're likely walking every day more than a half hour each way to get your water. So this is water poverty, and there are a couple of billion people in the world living in water poverty. And when they walk for their water, the water is generally contaminated. It's unsafe. And a friend of mine took this slide from a wall in Africa. What's the solution to water poverty? The solution is clean water. And China is now drilling wells in many countries of Africa to try and get the people clean water. And if you're out in a village in Africa or some other parts of Asia, here's what your water supply will look like. This is your well. And these are perfectly good wells. If you can pump the water out, then you can live a decent life because you can grow you can have drinking water and you can cook your meals and you can have everything you need for fresh water. So we've got a freshwater crisis. We human beings do not respect water. We abuse it. And in China, there's a lot of water abuse, as there is in all other countries, and you're trying to fix it. And we need more young people educated to know how to fix it. At the moment, much of the problem is figuring out how to fix it. So what is China doing to solve these water problems? China is doing many things. And if I had another lecture, I would talk about all the things that China is doing to fix these problems. So China needs to fix these problems so that China doesn't have the problems, but China needs to figure out how to fix these problems to help other countries fix their problems. So you have the Belt and Road project that you've all heard about, where China is helping the world become more modern, helping the world build railways and airports and everything. And as part of the Belt and Road program, then fixing nature is going to become part of it. So I lead something called the Groundwater Project, and we publish books about groundwater and the hydrologic cycle on a website. So if you want to know anything more about what I'm talking about here, you can go to our website. The books are free. They're written by experts all around the world. Some of the experts are Chinese scientists. Here are some of the book covers. So the books are written in English first and then translated. So we've got a few books in Chinese, and we're looking for volunteers to continue to do translations. So as time goes by, everything that I'm talking about here and much, much more will be on our website in a variety of languages, including Chinese. And Chinese scientists increasingly are part of this international project. So that's the end, and I think we've got a bit of time for questions and discussion, so I'd be very pleased for discussion.
Professor Cherry, now is the Q&A sections. Any questions to ask Professor Cherry? You can raise your hand. Okay.
Dear Professor Cherry, I noticed that you mentioned the important thoughts of drawing diagrams and imagination. So as middle school students who are all seated here, I'd very much like you to provide some suggestions. It's like, how can the diagrams and imagination be actually used in everyday education in school to improve our own minds about how to critically think the problem and to view the problem in a more scientific way?
So that question is the most important question now that I think about. And if we look at how education is taught everywhere, there's a lack of drawing these diagrams. So we somehow have to get into the educational system that we need to use our imagination more, because most of the important things are what we can't see. And the only way we can express imagination is to try and draw something. So, and when I look at books, so we need children to get in the habit of drawing their imagination. Now, in science and engineering, that's not the way we're educated. Artists are educated to draw their imagination. But it's even more important for scientists and engineers to draw. And Einstein is quoted as saying that if you've got an idea and you can't draw it, you probably don't have an idea that'll be useful. So you asked the question, I think, how can we get to do more of that? And the answer is, I don't know, but I think that education for students from grades 1 on up should revolve around nature. And the math and the physics and the chemistry and the biology can all be taught around nature. So for that picture of the cave, where we saw all those beautiful things in the cave coming out of the top and the bottom, to understand that, you have to write a whole bunch of chemical equations. So just about everything I've talked about here is about chemistry and physics and biology, and so we need to seek an educational system that wants to revise itself. And it's only in China that I found an interest in this. So one of the reasons why I'm happy to be in China is that there's an interest in change. This is the first time I've given this lecture. I gave a very short version of it at a school a few weeks ago, very short. And then I was delighted to get this invitation to lecture here because it forced me to prepare this lecture, and I've never stated these things before. So the answer to your question needs to come from China changing education. And what's interesting is that China is a country of change. I would never suggest this in Canada, because the educational system in Canada is frozen in time. It's frozen in time all over the world, as near as I can tell. But in China, you don't freeze in time. You're always looking for ways to change and move forward. So thank you. That's a great question.
Thank you. I actually have another question. And to be frank, we are actually the first generation to use new textbooks. So the new textbooks are totally different from what we used to get, and they encourage us to draw, maybe not draw, but to think more critically and to do more experiments. So maybe that's improvement in the way to think critically and actually draw out all your thoughts to improve your thinking. I have a second question.
If I could just respond to that then. So China is a country of innovation. Your leaders are encouraging innovation everywhere. That's coming into, innovation is coming everywhere. And then at the end of the day, I think that the real test of innovation in education is going to be drawing. Taking ideas and converting them into an image. And so that's hard. Like when I sit down and I'm going to give a lecture and I know my rule. My rule is, John, you've got to show it in an image, not just talk. And then I say, well, but I don't have an image. I've never had an image. So then I force myself to try and draw something. In some cases, I can't imagine it. So I use words. So this change is hard. It's hard to imagine and then draw images.
All right. So you mentioned sustainable pork. It's quite a creative invention, and I wish that there are many chances of water-based agriculture, and the use of AI is greatly encouraged in water-based agriculture. So is there any developments that you know about water-based agriculture and the combination of AI, since AI is been boosting in these past 5 or 3 years?
Okay. So in China, everybody talks about AI. You're an AI country. In the rest of the world, people aren't talking about AI enthusiastic. They're worrying about it. So when I ask about AI when I travel around the world, what are you doing about AI? The answer is, we don't know, but it's a big deal. In China now, you're encouraging, but let me say something about AI. When you go asking AI a question, much of what you get is wrong. So the challenge of AI is to sort out, when AI gives you an answer, what's wrong and what's right. So in my field, groundwater science, when I ask AI a question about groundwater, most of it's wrong. I said, well, AI is so stupid. How can AI be wrong most of the time? AI is wrong most of the time because AI just pulls out, AI doesn't have its own imagination. AI can't tell the difference between right and wrong. AI goes out and finds all the information and packages it. So your generation, and you're faced with a real challenge. When you're using AI, don't just take it. You have to think about it. And much of what I'm talking about here, you wouldn't get from AI, because AI doesn't know it. So AI is a fantastic tool to make things go faster. It'll save you all sorts of work, but it doesn't yet have an imagination to draw diagrams. Isn't that interesting?
All right.
Now, AI, as I understand it, AI is trying to get to the point where it can draw diagrams from imagination. But at the moment, it can't. At the moment, it gives you things that are either wrong or stupid. So you're in the first of the AI generation, and you need to figure out how to not be ruined by AI. Anyway, what was your question?
Well, I think that's enough. Thank you for your deep understanding.
Good
Yes.
morning, Dr. Cherry. I want to ask is that you have talked to us about the root of trees in the past. And I want to ask is that if the tree dead, if the tree was dead, and if will its root flows into the underground water, and if the tree's root absorbs some kinds of new chemicals in water, will it cause to the water pollution?
You want to repeat that question? I think it is asking about water pollution, chemicals,
The first question is that if the tree dead,
Is the tree dead?
Tree dead, if the roots is very big, yes, and it will, and will it flows into the water?
Well, when a tree
In the underground water.
so when a tree dies, it doesn't harm the water. It just stops pumping the water up into the atmosphere. If I got that correction right, but trees purify the water. So if we lose our trees, we lose the ability to purify the water in the underground.
Okay.
Was that answering the question?
Okay. The second is that I want to say that will the root absorb the chemicals in the water?
So this is an important area of questioning. Can trees help purify water? Or do the trees concentrate the pollutants? But many trees actually purify the water, and there are areas where the soil is contaminated and people plant trees to help clean up the environment. So no matter how you look at it, trees are helpful. Now the chemicals that the roots take up in the trees, the tree doesn't send them into the atmosphere. So the chemicals don't disappear. The harmful chemicals don't disappear. but sometimes they degrade. They change into less harmful chemicals. So if you have an area where it's all contaminated and the soil is contaminated, in many cases, one of the things that people do is plant trees. I hope that helped answer the question.
Okay. Thanks.
Okay. So may I say that I understand in China that children in school take English 1 hour a day from grade 1 on up. And I can see that it's doing amazing things. And 1 hour a day is lots. In Canada, when we study, our children study French, it's not that much. So the fact that Chinese children are being educated to handle English in a useful way is so powerful, because then you can be part of the West, and you're in the East, and that's the best of all worlds. I wish I could understand Chinese. I'm too old, and it's too hard. I have to study too hard to understand Chinese. Yeah, question? Another question there? Yeah.
Professor Jerry, thank you for your talk. And what advice would you give to a kid like me who wants to help protect our groundwater?
What advice would I give to a child who wants to protect groundwater? Well, I think the starting point is to be aware. The starting point is to be aware of everything that you do in your life. How does it affect water? A starting point is for you children to educate your parents. Your parents are a problem. All parents are a problem because they're educated in the early period. So the younger generation has to convince the parents to maybe pay more when you buy food, to buy the right food, etc. So you younger people have to then be very aware of everything that goes on. Is it harmful? Is it helpful to nature or harmful to nature? Okay, that's the question with regard to everything. And so you just start paying attention. When you're eating some food, ask the question, well, where's it come from? Is it healthy food? How would you know if it's healthy food? Well, maybe you'd go into AI. So one of the wonderful advantages you have of AI is you can get answers to questions so quickly that you can figure out the question. And then you have to figure out the next question to figure out whether AI got it right. So your generation, then, you're going to be the AI generation, and you need to figure out then how to use AI so it moves you forward in the right direction rather than the wrong direction. What a challenging world for young people. Wow. Exciting world. Exciting because you're in China. Not exciting if you're in some other countries where there's nothing but problems getting worse.
Thank you for your answer. I will do it in the future.
Hello, Professor Cherry. First, my English is not very good, and I hope you will understand what I want to explain. I have a question that is currently not very practical. And now we are committed to researching the groundwater's protective measures. As of now, the management of groundwater has improved, but I don't think it is a long-term solution. We all know the groundwater is a non-renewable resource. Maybe one day the groundwater will eventually dry up, although it seems far away from now. And I'm wondering what will happen if groundwater dry up, and what will people do to face this problem?
So I guess the question was, well, what will people do if groundwater dries up?
Yes.
Okay. That's a very important question. So in countries that don't have enough water, they have to make fresh water. So you can take seawater and you can convert it to fresh water. So, and any country can do that if you have money. So you can take seawater and make it fresh again, and you can grow crops on that, but you need energy. So energy has to be produced at a low enough cost. So a country, so if a country has wealth, like Singapore, Singapore produces their water because it's a little country and they don't have enough fresh water. They get their fresh water by using energy to produce fresh water from seawater, number one. And they get fresh water by taking the sewage, like all the sewage when you flush your toilets. They take that dirty sewage water and they purify it to fresh water. So in Singapore, they drink their sewage. And in Los Angeles, they drink their sewage, but they put it in the well first. So humanity isn't going to run out of fresh water if humanity has technology and resources. And in China, you produce electrical energy now at less cost than any other country in the world. You're building nuclear reactors more than all the rest of the countries combined. You've got solar and you've got wind. So in fact, if you've got energy that's low cost, you're not going to run out of water. Yeah, and that's why. So China's focused on producing electricity at a low cost, and you lead the world. So in a way, China's the least likely to have water problems because at the end of the day, you can make it. Now, you have to be willing to drink your sewage. So in Singapore, how do you get people to drink their sewage? You have to have a propaganda campaign. So in Singapore, they had a propaganda campaign explaining to the people that you're in Singapore, and if you want to drink fresh water, you have to drink their sewage. And that's what the people do. They did it with a propaganda campaign. But you don't have to do that yet in China because you've got lots of water. You can move it around. So you're not going to be drinking your own sewage.
Okay, thank you, Professor Cherry. And I hope in the future all the world will have enough water.
What's that?
Thank you.
Dear Professor John, this is Elaine. I benefit a lot from your lecture today. I have a few doubts and hope you can answer them for me. First, what experience made you decide to start researching groundwater and water environment?
Oh, what caused me to become a groundwater scientist? I graduated from high school and I went to university in geological engineering, and in my second year, at the age of 18, I attended a lecture. A professor came in, a new professor, and he gave a lecture. I was sitting there very tired. The lecture was early in the morning, and this professor spoke totally enthusiastically about groundwater. Nobody had heard about groundwater. And he said to the class, my advice to you is to go on in life and get an education and study groundwater. So and he said, I've got a summer job for somebody who wants to study groundwater. And I was 18 years old. And I went over and applied for the job, and I got the job. I was very proud. I thought I was so smart. And then he told me I was the only person who applied. So back in that era, nobody in geological engineering would study groundwater. They would study minerals, they would study oil, they'd study gold, but not groundwater. So how did I get into studying groundwater? Is I was fortunate that I got out of bed in the morning and went to a very early lecture and had somebody tell me that. And he was the only person in the country, I learned out later, that would ever tell students that. So the answer was, I was very lucky. Thank you for the question.
Next, what do you think is the most meaningful aspect of being a scientist?
Oh, do that again. Say that again.
What do you think is the most meaningful aspect of being a scientist?
Oh. I read that question. What's most meaningful about being a scientist? Well, so most scientists I know who are happy with their work are happy with their work because they have a job that pays them well enough to live, solving puzzles. So most scientists who are happy with their work are happy because they get to try and get answers to questions that are interesting and important. So when I'm with my colleagues, my other groundwater scientists, just talking, we have a wonderful time talking because we're talking about how we're trying to solve all these interesting problems. And we're happy because we can talk to one another about our little problem that's narrow. So we're happy then to find somebody who's interested in the problem that we're interested in. It's like if you play chess. Chess players are happy when they find chess players to play chess with. Scientists are happy when they find other scientists to talk about their little problems with. So we scientists get to have a job where we get to have fun, if we're lucky, and have a good job, and if we're in a good country. Thank you. Good question.
Okay, we know about underground water, and thank you very much.
Thank you.
All right, since time is limited, I see you have so many good questions. If you didn't ask, don't worry, you can ask after the lecture, all right? Okay, let's thank Professor Cherry again for his great lecture. We
Thank
have
you.
the last
What a
chat.
wonderful audience. Thank you for your attention after such a long lecture. In Canada, I would never be allowed to give such a long lecture to children. Be disallowed.
Maybe this is the last one. I'm from Hangzhou. Basically, we're traveling with two of my students. I'm teaching there in a university called Beihang University. So I come all the way to just participate in the lecture. This is a fantastic lecture. I enjoyed very much, and it is informative. It is, you just showed that the processes that are fundamental to understand the groundwater system, the river, the ecosystems, the way we are, creating pressures on groundwater and contaminate all those things. It also informs many things to us, to me as well, and at the same time, I have identified that some of the problems, the way we perceive in the global arena, like climate change, like sea level rise, those are not the factors. Rather, groundwater extraction that is, causing the sinking problems. Those are more important to pay attention than the sea level rise. So some of the new facts also come into mind to look into, and also it also gives. I work with the remote sensing technique, so I also saw a number of new avenues to explore more of these issues, to check some of the fundamental principles and the processes that you mentioned, like the GRACE satellite that works on the gravity anomaly. So gravity anomaly, if it could be determined by using the time series GRACE data, then we could be maybe connect with the gradient of the groundwater table. So that way we have the data for all over the world. So that particular data could be converted to test your equation, whether from a passive data source, could we think of identifying the slopes? And that is very important for many ecosystems like Delta, from where I come, from Bangladesh. We have huge arsenic problem in the groundwater systems, just because of that arsenic from one water table is going to downstreams. So we need to know the gradients and the slope conditions. So sometimes we don't have enough data from the in situ observations. So so there might be many different ways we could just think of all those issues. So it gave us new thoughts to investigate the process. It gave us very simple way how should we just look into the matters. So I have no question, but I would like to thank you so much. It's a nice presentation, a very nice, easy talk. And also I'm very impressed the way the questions were raised by the students, especially the fundamental question. The first question was really, really good. His question was that the imagination and diagram, how that could be brought in the education system. So that is also a kind of thought that struck me, and that I will also use, is there any technique that we could invent to make sure that all the students will be in the exercise, they will just bring their diagrams, there will be dialogue, there will be competitions, and new results will emerge where imagination and the diagram will be together. So it's a fantastic day for me to be here. Thank you so much for the organizers and for Dr. Ivy and you and all the students here. Thank you so much for my side. Thank you.
Thank you for those comments. Very good.
Okay, now let's welcome our Principal John to say something. All right? Okay, let's give a big hand.
我的英语没我们同学们好，所以我就讲中文了啊。其实呢，我想要讲的，刚才我们同学问的问题跟我们杰瑞教授回答都已经包含在内了。我主要是想讲什么呢？第一呢，我们今天是第一次听这样一个全英文的报告，是吧？而且杰瑞教授表扬我们说，他在加拿大不会有这么长时间给孩子们听。我们整整1个半小时，我觉得非常不容易。同学们听得也非常认真，问的问题也非常有质量。第二个呢，我们是第一次尝试这样的这个现场英译中。那么这个人工智能呢，其实还是有些问题的。所以大家不要去介意，理解大概的意思就可以了。有些出现的这个词都不大好，对吧？所以这个是刚刚杰瑞教授也讲了。这就是人工智能目前还存在好多问题的这样一个现状啊，这是我想第一点要想表达的。第二点呢，其实刚刚同学已经问过了，就我们搞这样一个持续4个半天，然后我们教育集团全程直播的这样一个活动，我看了一下，我们4个半天线上线下总共要超过45000人，45000人线上线下。这个传播的这个面应该是非常广的。那么为什么要做这样一件事情？其实就是为了让孩子，让我们的同学接触到更大的一个世界，不仅仅是课堂里面一点知识。这个更大的世界是什么？包括我们今天杰瑞教授讲的是水污染、地下水，对吧？我们前2天讲的是天体物理学的，就我们从上天到入地都讲了。那其实是什么？引发大家的一个思考，就是你要有好奇心，你要有勇气。就比如说我们今天的这些同学的这个提问，我们前2天同学们提问也非常积极，要有勇气去跟专家面对面的交流，要有勇气去做什么？就你有一个想法，要去验证，要去实践，而不仅仅是我光有一个想法。不仅仅是我读了这些知识，我学了考试考了100分或者是90分我就满足了，而是要有更大的更广阔的一个世界，需要你们去探索去实践，要有好奇心，坚持不懈地做下去。就像刚刚同学讲的，杰瑞教授为什么对这个他的那个水污染、地下水污染那个专题感兴趣，是因为他听了这么一个讲座。我相信我们这几天下来也会有更多的同学对相关的这些问题，包括不仅仅是这些问题，还有其他的好多问题，都可以有自己的 好奇心、想象力，然后持续不断做下去，最后成为我们有一句话叫“今天你以新松为荣，明天新松以你为荣”，好吧？我就想讲这么几句，谢谢大家，也再次感谢杰瑞教授。
Okay, finally, to thank Professor Cherry for supporting our school science education, let's welcome Principal Zhang again to give him a special certificate. 下面我们有请张毅校长为 John Cherry 教授颁发新松中学教育集团校外科技教育导师荣誉聘书，我们掌声欢迎。
Thank you. Thank you. Very good.
Our lecture is coming to an end. Let's thank Professor Cherry again with our warm applause. Okay, that's all for today. Hope everyone really enjoyed it. Okay, see you next time.